Good afternoon. First of all, I would like to thank you for your presence and allow me to share with you issues relevant to the universe of designers and consultant in HVAC segment. As a brief introduction for those who don't know us, IMI Hydronic Engineering is a company specializing in hydronic systems belonging to the British IMI Group. Our product portfolio includes pressurization and water quality devices, as well as valves and actuators that ensuring the optimal functions of the HVAC systems, either in the full or partial operation. Here we have the main topics that we will be covering today, and I can highlight the key three. The first one is time saving and money. The saving of time in performance hydronic calculations and consequently the financial gain. The second one about the technology transfer, the shift in technology standards for latest in selection tools and new product solutions. And the last one, the partnership in the development of hydronic projects, having as a support our worldwide instruction in hydronic solutions, both the support in thermal efficiency and also energy efficiency. When we look at the scope of our work and its importance worldwide, is it possible to understand the impact of our job when we're talking about sustainability and consequently the consumption of neutral resource? When we look at the numbers, we can understand this message. HVAC system represent about 20% of the total investment in a building. But when we look at the number about operation cost, these numbers is bigger. It is responsible for 50% of the building's energy consumptions. This value can help us understand not only the importance as a well-structured of a project according to the customer's needs, but also the importance of their harmony between implementation and operation costs. In addition to the macro importance of our performance at the global level, we can converge this view with a specific view of the value attributed to the investor of the project in question. From a commercial building, for example, the thermal deviation of 1 Celsius degree cases a reduction of 5 to 6% in human efficiency. When we look the total cost in a building, the people represent 90% of this value. In other words, in 2019, this 1 Celsius degree deviation generated a loss of around 250 billion in Europe. And why invest in an efficient hydronic system is so important? Not only because it represents 50% of the operation energy consumption, as I said some slide before, but also because the 1 Celsius degree more in a hot water system represent an increase of 6 to 11% in a system energy consumption. And the 1 Celsius degree less in a cold water system represent an increase of 12 to 18% in a system energy consumption. So it's not a small numbers, right? In addition to the macro and micro impacts, we have a comment on. We live in a dynamic world with excess information and constant changes happen at speed not previously experienced by us as a society. We are talking about new legislations, technologies, requirements, and ways of doing business, all of them founded by serious and renowned organizations to make safe improvement for us and for the environment. as we can see here in the slide with some examples of this company. When we face the reality of the world of projects, what are the main challenges that we can highlight for the segment? Here we list three which we consider are the main challenges, and we will use this opportunity to unravel each of them with great level of detail. The first is related to increase in the complexity and the requirement of legislations and regulations for the installation and operation of the HVAC system. This concern the reduction time and short budget for project development, and this budget and execution time issues is often associated with the devaluation of teamwork of designers or even the investor's lack of knowledge regarding the importance for your return in this stage of the project. The third and the final challenge is related to the investor's demand regarding the performance of his systems, but at the same time, his lack of technical knowledge regarding the HVAC universe. I would like to ask a question to all of you. In face of so much information, constant technical updates, and the countless devices that are specified in HVAC systems, do each you even needed to specialize further in each component specialized in the systems? I mentioned before new standards and certifications, but why should we use them as a guidelines during the development and implementation of projects? In addition to the security provided to tenants, certifications bring the investor a guaranteed market competitiveness, contribute to the reduction in consumption of energy and water, reduction of CO2 emissions, and waste. Additionally, depending on your location, some certification labels grant tax incentives. Based on the data provided by the Energy Performance in Building Directive, buildings that hold their certification showing 25% reduction in the consumption of energy, 11% reduction in water consumption, 34% decrease related to CO2, and 8 million tons reduction of landfill waste compared to the buildings before compliance. In addition, tenants are willing to pay up to 30% more than the certification space. All the highlight topics in this slide help us to understand the importance and the benefits to using standards and the certification as a guidelines during the development and implementation of a project today and also in the future. Moving on to the second topic, we will talk to the issues related to the runtime and the small budget allocated to the project development. A difficult equation to solve regarding issue is not only the time it's taken to calculate a hydronic system, but also the numerous resizing requirements that will eventually occur along the way. How can you balance the time of execution of this work with the amount charged and at the same time maintain the quality of the service delivery? Another point in which are constantly faced with it is the absence of the total volume of water in the system, or even the time to obtain it efficiently and with confidence. Is it possible to do it quickly and safely? And when we encounter systems that operate in a complex and dynamic way, and we must predictive and a factor of simultaneity in order to ensure to the investor a reasonable budget and the precise operation conditioning. Is it possible to resize the hydraulic system such as pumps, pipes, valves, valves, etc., in order to confidently guarantee performance. For those who have never heard or perhaps did not know all the functions of our tool, the HySelect software developed by us is a tool we use it not only for a simple selection of products for the hydronic network, such as valves, dirt and microbubble separator, etc., but also a software that can assist the hydronic calculation, including pipes, the lever of pump head, balance and control valves and the respective authority, the position of the differential pressure sensor, and much more. Any changes that occur to your system, such as flow, hydronic redirection, the program will automatically resize all selected devices, thus optimizing any reworking that may be necessary. With this tool, it will be possible to quickly survey the total volume of water in the system and, consequently, easily calculate the capacity of the expansion tank and its respective pressure class. Note is the quick and easy inclusion of simultaneity factor, optimizing the initial investment by the owner without compromising the operation needs. And the last highlight is the delivery of calculation reports and a complete bill of materials. Started the last topic, we will discuss the challenge associated with the needs of the investor. The expertise and business focus are not at all related to HVAC. This is just one way to ensure that the building operates as efficiently as possible. In this third topic, we will discuss the low investment available, but how at the same time they expect a high operation performance and low operation cost. They expect associating products with high technology on board, but that are also be easy to install and operate. And the last topic, that delivery a guarantee of performance and, if needed, real-time technical support. So, let's see these three important points in practice. When we talk about a low investment and high efficiency, we are referring to the best relationship between the solution and its initial and operation cost, both for new buildings or renovation, like retrofit. In assisting the selection of product, either individually or systemic, and their respective operation costs, we can mention the high tools, the mobile app for simple selection, and the other hydronic calculation that can help you when and where you want. The pressure expansion tanks, air dirt separators, differential pressure balance and control valves, radiator valves and radiator capacities, and etc. The second one is the HySelect, the software for selecting and calculating your hydronic distribution, as I said previously. And the last one, the energy calculator software, I too developed for the calculation of operation costs, involving several variables and enabling to calculate the payback of improvements proposed, a language that I am sure the investor is more likely to understand. So far, we have discussion about tools that will serve as a great support for the best selection and conceptualization of the investor's HVAC system. Now, we are going to cover the three fundamental steps to achieve, in reality, the best operation condition, including guaranteeing the maximum load of power required by the project without spend more than we really need. Ensuring precise control when the maximum load is not required, that is, in partial operation conditions. On average, we need 50% of the load in 8% of the system's uptime. The third foundation is the guarantee of thermal efficiency, the lifetime, and the operation cost of the system, maintaining the quality of water. The use of suitable devices to guarantee the maximum power of the system can provide the consumer with savings up to 35% of energy. An interesting fact regarding partial load is that a system that operates as on-off, it means 100% open or 100% closed, consumes on average 7% more than proportional systems that has control in intermediate conditions. And 1 millimeter of dirt in a boiler, for example, can cause an increase in energy consumption of up to 9%. How can we better understand the values of 35%, 7%, and 9% related, respectively, to the maximum operation costs, precise control and partial loads, and increased consumption due to the deposit of dirt? The next slide will report of those values. There is an interesting fact when it comes to the maximum operation condition that show the relevance and the impact it generates in the HVAC installations. About 90% of the air conditioning projects operate with a surplus of 50% of flow in relation to the project value. Besides the increase in power consumption caused by the overflow, what is the most dreaded consequence by investors that these problems brings? The tenant complaints. Due to the thermal discomfort and the increase in their monthly energy bills. Quickly mitigate the problem, emergency actions are taken to avoid or minimize such occurrences. Unfortunately, they actually lead to even bigger problems for the system. Proposing its oversizing, putting it in the maximal setting, replacing it with more powerful pumps, thermal units, forcing its operation in conditions of low efficiency, and compromising its lifetime. Engineering resource, time wasted in a search of solutions, incorrect solutions being applied without real understanding of the problem, absence of the adequate diagnosis leading to unfounded decision making. How does this problem occur and how can it be solved? As you can see, it is hydraulic distribution. There are three equipment whose flow rates represent 90%, 85%, and 80%. This percentage difference occurs due to the unbalanced head loss in each terminal unit, which is properly adjusted with the introduction of hydronic balance valve. We will not go here on a specific type of balance and how to realize them, but it's important to note that there are different methodologies to balance a hydronic system, and the T-scope instrument, as you can see from this picture, is a device that embodies all these capacities and provides to your operator that the project flow is actually being met. In addition to the simple measurement and the most sophisticated balancing methods, the T-scope also helps in diagnosing problems and can even create a measurement data log for a period of time. If you are interested in understanding the balance with a great level of detail and how this adjustment impacts the pump head, for example, We can address these issues in another technical presentation. Remember that it is this hydronic balance that we allowed a reduction in energy consumption of up to 35%, informed in the previous slide. When we speak of a current control of partial part load, also known as a control authority, and the reduction of energy consumption of a proportional versus on-off, it's necessary to understand how the relationship between the thermal unit curve and the curve of the control valve. When we look terminal unit alone, we observed an exponential relationship between the capacity and the flow as shown in the graphic. When we want, for example, to work at 50% of the machine's terminal capacity, we must allow only 20% of the designing flow to the pass-through. However, when we analyze the curve of the control valve in isolation, we can see that this relationship between the design flow and the percentage of its opening is also exponential. However, it represents a mirror of the serpentine curve. The harmony between both curves represents the linear relationship between the thermal capacity of the thermal unit and the opening of a control valve. As you can see in the example of our slide, 50% of the thermal capacity is equivalent to 50% of the opening of the control valve. As we saw in the first slides of this presentation, HVAC systems operate around 80% of their time with less than 50% of their total load. When we analyze this data and connect the fact that on-off valve makes it impossible to operate the machine under 100% of capacity, we can understand why substitution of actuators on-off by proportional once made reduction by up to 7% power consumption. The harmony between the characteristics of the systems and the control valves is fundamental for the operation efficiency and the combination of devices with cutting-edge technologies, guaranteeing a high controllability and precision associated with a digital adjustment tools will deliver to the consumers the sum of modernity and simplicity demanded by him. Now, finally, let's talk about the lasting foundation to guarantee the best operation conditioning. Can water quality cause the thermal inefficiency to the point of increased operation cost of the HVAC system? Can this factor compromise the system, even if proper devices were selected that consider the maximum power and operation at partial loads? For both questions, the answer is yes. Even for state-of-the-art devices, performance and durability are affected by inadequate water quality. As we can see in our example for GIN 2440 of 1-inch steel pipe, a light rust layer of 0.15 millimeters can cause a 15 to 25% increase in pressure loss. For a medium rust layer, 0.5 millimeter, the increase can be from 50 to 80%. And for a high rust layer, 1 millimeter, this increase will be from 125 to 170%. For these types of occurrence, we can think of devices that, in addition to being efficient, allow to the cleaning of dirt without interrupting the systems, relevant for installations that operation 24 hours a day and from Sunday to Sunday. Still in the universe of water quality, we must think about the case and consequence effects, asking ourselves, how did the air migrate or appear in my installation? How do I prevent its entry, and what device should I use to fight them properly? In this presentation, we will not address all the points to answer these questions, but it's necessary to understand that maintaining static pressure in the systems will prevent air migration into the system, and consequently prevent the occurrence of cavitation for corrosion, a phenomenon that reduces systems life and quickly compromises control. If you want to go deeper into this discussion, we can schedule a specific conversation about it, or even share technical documentations that talking about the facts of the case and consequence. I will just leave you with the fact that accumulation of air in radiator, for example, can reduce the power of a unit by up to 8%. After the technical discussion regarding to the maximum power condition, partial load control, and water quality in the air and dirt requirement, it is worth asking, is it possible to analyze in isolation the device installed in the system without thinking about the operational connectivity between them? Can a product operating correctly compromise the operation of all plant? When we're thinking of hydronic systems, we think of an interactive body that requires effective performance of all devices in order to deliver the bottom line. So the connectivity between pressurization systems, water quality, appropriate balance, and precise control in partial situation is of paramount importance to reduce operational risk, while optimizing its operation and provide real-time information for quick evaluation and decision-making. A complex system developed for a specific investors requires integrated solutions that guarantee a low initial investment cost, a high operation efficiency, and a simple installation and maintenance. Closing the third topic of the investor's need and meeting his demands today, we can highlight key requirements. The first one, documents with details of the operation and with precise measurement that guarantee the investment and its payback. The second, real-time technical and commercial support for your projects. And the last one, fast assistance for maintenance teams. At the final stretch of this presentation, we can say that ensuring the success of the project is hammered for the three important steps. Each are related to the correct initial concept in the design phase. The second, the correct installation of the device. And the last one, the startup of the systems, take into account the real operation situation and the correction of any oversized equipment in the initial design phase. In this example in question, we are considering the two initial phases, design and installation, carried out with excellence. However, when we encounter the third and the last topic, we have a question mark. What does that mean? A global fact that calls our attention and how this step can compromise the work performance in the design phase. 75% of buildings in the world work outside their optimizing operation point and do not deliver to their investors what was foreseen in the design phase. In this video, we will adjust the flow at the last machine until reacting the flow rate of 100 liters per hour. After that, we will close 100% the middle valve and we can see that nothing will change. And finally, we will change the frequency inverter oscillation pump head from 20 kPa to 80 kPa. And notice, nothing will happen with the flow rate of the finish, the terminal units. So let's see the video. Adjust the flow rate, the last machine. Close 100% of the middle valve and nothing changed in flow. And finally, we will vary the frequency of the inverter oscillation pump head. 20 kPa, and we'll up to 80 kPa. And as we can see in the terminal unit, not change. The flow continue the same. So the question for this video is, what does this video show us? Even with the correct devices in the terminal unit, we can still erroneously adjust the pump's frequency inverter, causing it operate above the required maximal power and consequently consuming energy behind its project value. To show in practice the importance of the point of operation and the systemic expertise for this adjustment, we will show a real case of data center in Brazil. This is an existing project with IMI balance valve installed, but that were wrongly adjusted. Hydronic commissioning was carried out just by adjusting the existing balance valves and set points. By positioning the system in the correct operation point, the flow reduction of 60 cubic meter per hour shut down one chiller and result in a 6.35% reduction of energy of the whole building and increase in the classification of the data center, the power usage effectiveness to 1.7 to 1. From our technical conversation today, we can conclude that to maximize your HVAC system design, we need to meet energy efficiency standards today and in the future, provide precise and stable internal comfort to the users, find the best initial investment and operation cost ratio, meeting the demand of investors, and be able to fit everything in the time frame and cost bracket for the development of your project. This conceptual presentation was meant to present the systemic support that IMI Hydronic Engineering can offer you to contribute to your daily work and developing project. It is important for us that we emphasize that knowledge sharing is a key part of our company's DNA. Either it is related to our products, the selection tools or system in which they are installed. Feel free to contact us on any support you may need. Thank you.